calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. The universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. Fields and forms, math and voids, it all sings with one voice. It's boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in
see, folks. I think that we are ready to go. Hey, everybody. Welcome to Skytour Livestream. It is your concierge to the stars, Mark and Daryl. Daryl's with us. Hi there, Daryl. How's it going?
Hello, Mark. I'm okay. How are you? Hello, everybody.
I'm doing good. You know, Calabos was putting out on the different groups. He put out to like hundreds and hundreds of people that were doing the streaming. And what I found funny was he wasn't wearing his glasses. So he wrote, come out to Skytour live stream with Daryl and Mark the Astro Master. He called it Astro Master. He meant to say astronomer. So Astro Master. I mean, is that like kind of like Master Blaster? Remember Master Blaster?
Oh yeah.
Wasn't that like what's her name?
Mad Max Beyond
Thunderdome, right?
Yeah, the third one.
That was Tina Turner.
Yeah.
Yeah. Master Blaster.
Started out okay. Got really dumb.
Yeah, well,
Yeah. Mad Max 2, The Road Warrior. That's one of the greatest movies of all time.
It really is.
Yeah.
I enjoyed that. Yeah.
I bet I've watched that thing over 100 times easily.
Yeah, the uncensored one is actually the one to watch. You don't want to watch the ones that have been censored because you just lose so much of the movie, and some of it's gory, and they censor out some of the gore, but you don't get a feel for the great waste unless you actually see the cruelty. Like Bernard had to cut off his own foot to escape. I forget which one it was. But anyway, welcome to Skytour Livestream, everybody. This is the first live stream in a while, only because we've actually had a lot going on here. We had I got news to tell you too. If you listen to our show tonight on Skytour Radio, which premiered from 6 to 8 p.m. tonight on KGRA, Tara and I made an announcement that the Benson telescope equipment has been purchased. And we are changing the mount for this telescope that you see up here. This telescope is going to have a mount that is going to be far more robust, and it's going to use the same exact server and technology that the one in Benson is going to use. And so we actually bought two Skywatcher EQ Pro mounts. One for this
EQ6 Pro.
EQ6 Pro, yeah, for this telescope, and one for Benson. So this is gonna be Skytour Sonoran and Skytour Benson. Now, here on the East Coast, we are going to have Skytour East, and that's actually going to be a solar observatory. I already have the solar telescope, and I've tried it out and checked out how it's going to work. It looks like it's going to deliver quite a good performance. So we're going to be able to look at the sun during the day and see the prominences, and maybe do some time lapses, and then at night we will be doing the deep sky. This telescope is the wide field. This field we see here is 1.5 degrees wide by 1 degree tall, and this is the telescope that we're going to do all of our wide field nebulae with in large expansive areas, and on many of our mosaics. The Benson telescope is actually going to be a similar telescope, but it's going to be an inch larger in diameter. It's going to be a Celestron 11. And we're going to have a filter wheel on the back end. That's where the camera will be on this one, because we're not going to be sticking the camera off the front like it is on this telescope. So we're going to have that telescope set up so that we can do very, very high-end deep sky shots. And what that's going to give us is the ability to do what is called like the Hubble palette, the hydrogen alpha, sulfur 2, and oxygen 3. And those are going to be 3 narrow bands. And so what you do is you take, let's say we're doing this galaxy right here. This is, of course, Messier 81. right? That's this galaxy right here. And Measure 81, this galaxy has a specific time that you would use to capture all the detail, and for us that time is 15 seconds on this scope. Now, if we shot it in narrow band filters, they only allow in certain details, certain data. Okay, so the H2 regions in this galaxy would come in if we shot it with the H2 filter. Okay, and that's the ionized hydrogen filter. And then the oxygen 3 areas, the areas that glow green like supernova remnants and so forth, that would show up with the O3 filter. And then the sulfur 2 would capture the older stars along with some of the nebulous detail. And you combine all three of those to make a final image. And the final image could look very much like this, and maybe with more detail. But with that new telescope, it's going to be bigger in our view. And to give you an idea of how much bigger, let me just give you an idea, right, by just moving in on this. Okay, our native view of that telescope, with that telescope, is probably going to be somewhere around here, maybe a little more. Now, right now, we still have sunset out there, so you can see we have a little red haze here. I can kind of kick some of that out just by playing with it like that. Right, do a little processing there. So this in Measure 81, this galaxy, it's a beautiful spiral. You can see these arms. They're really well designed, well thought out, I would say, right? And you can see these wonderful deep details in here. And what I'll go do now is I'm going to turn on the unsharp mask here, which is going to give us a little slightly more punched up detail. There it is. And this is cool. This is cool.
Izabela's here.
Izabela. Hello, Izabela. Izabela, thank you also for listening to Sky Tour Radio tonight. That was very nice of you. I'm glad you were able to come in. Let's see, right. Yo, burb. I know. Be right back. Old school. Hey, you know, I had a good time in Arkansas. I was in Arkansas at the Ozark Mountain UFO conference. And my talk was, well, according to some, they really enjoyed the talk. And next week on Sky Tour Radio, we're actually I'm going to do that talk for you guys. So if you want to join us on Sky Tour Radio, you're going to see the talk live on Sky Tour Radio. And I started talking about it a little bit tonight on Sky Tour Radio, but I will be doing it more extensively next week, and you'll hear a little bit more about it. The gist is that we're going to talk about how unidentified flying objects, or UAP as we call them nowadays, could actually be here. The physics that would allow them to actually be here. And it's in layman's terms. I'm not going to go over anyone's head. I'm not going to foist off Maxwell's equations on you to help you understand what's going on, because you need some advanced physics classes to understand that, probably, unless some of you do, in which case we can talk about it offline. But for the bulk of the folks, I just want you to understand the basic concepts about how UFOs can actually move from there to here. And here's the kicker. They don't actually traverse the distance between here and there. They basically punch out of the 4 dimensions we live within and go to another dimension and then come back in. Now, as woo-woo as that may sound, it is not woo-woo at all. It's actually real potential future physics. It deals with string theory and so forth. It's really incredible. So when we look at a galaxy like this, could creatures be here from there? Well, the answer a couple of years ago might be absolutely not. That's ridiculous. And now, that's something that might actually be within the realm of possibility. Isn't that something? So I'm pretty sure that's the only way they can actually be doing this. And I'll be talking about that next week on Sky Tour Radio. So I want to say hello to people that are here. I know that we had some early birds. I guess Michael Hedrick. Man, that guy, Michael, you just jumped right on this. I'm glad you got the alert. James Hyatt was right there in second place. That's fantastic. And then Old School's with us. And I believe you're in Arkansas, like I said, I think earlier. And then Fantasy's here, and Fantasy is going to be ducking in and out because it's a clear night there where he is, and he's probably going to be looking at the night sky as well. I think that's a great idea. And then from Belgium, we have Mr. Django. What's going on, brother? What's happening? I am really happy you're with us tonight. And so, you know, we're going to be, since it's galaxy season, we're going to be looking at galaxies. You know, and Daryl's got a few ideas, too, for galaxies he wants to see tonight, and we're going to look at them. So
Hopefully.
Yeah, hopefully, yeah. So we're actually at this time, look at the number here. We're at 73, but you know what we're going to do? I'm going to do something unbelievable. I'm going to clear this entire stack. And why? Well, because we have sunset light in our view right now, and it's kind of polluting our light a little bit that we want to see. All right, so we're going to let this kick in and do another set of exposures. This is Messier 81. Okay, gorgeous galaxy in Ursa Major. All right. Donald is with us. Donald Dean, how you doing? XL 500. He goes, that's covered in Hitchhiker's Guide to the Galaxy. Well, sort of. I think that's kind of funny. Of course, mice own the world, don't they? In that Douglas Adams novel, which I think was great. All right, let's pull our black point over, because this black point dictates how dark the background gets. And then we can drop this mid-level to actually help get rid of some of our noise, to allow some of the detail to peek through early on. We've got 4 stacked. It's only a 15-second exposure right here. We can do this at 25, 30 seconds, 2 minutes, but why make you wait? Why make you wait, right? So, these stars, as you know, are all in the foreground up here, and the galaxy is way, way, way back here, you know, and you can't even see it because it's not even in the view. It's way back here, you know. And for those that are just joining us, we have there we go, a satellite just came through. Okay, this is our current view. All right, this is our wonderful planetarium that we have attached to the telescope to guide it. I included that in here just to make it kind of a nice overall thing here. This galaxy, according to this, is 12 million light years away. And what we don't see readily that much when we take pictures of this galaxy is the other one that the satellite is about to pop through. There's this little guy over here. Now, we've only got 8 here, so you see this noise in here. This is noise. If we zoom in, you'll see the noise. Okay, here we go. See that? The modeling? That's noise. And we get rid of that, okay, by stacking. And what we do by stacking, and many of you already know this, so pardon me, this is for the new folks. What stacking does is it allows us to take an image, take a second image, align it with the first, and stack it on top. And just make an image sandwich all the way up like that. The image sandwich is really cool because that allows us to take a photograph without noise, because the dark, fine detail, like this little arm in here, this little part of the spiral arm, okay, this stuff right there, all right, would be lost in the haze of noise if it wasn't for stacking. So that's really cool. The detail in the spiral arm here, this stuff out there, this young star forming region in this arm is something that's visible because we are stacking and can start to see the separation. And so it's not just a fuzzy mess. It becomes something that's really, really beautiful. And that'll happen over time. We got to just let it come in. So, and I want to just thank Commander Cobra for my glasses. He sent me these nice glasses, Commander Cobra's on KGRA, on UFO. It's a roundtable show. What is the name of that show? UAP Crossfire. And they want me to host it with the others on a couple times in the coming up in the next couple of weeks. So I'll be doing that with them. They're all good folks, good friends. So we have that to look forward to. Michael Hedrick says, Mark, seeing the telescope at that point in the sky and then seeing it live view is just awesome. Oh, you mean where you see this, where you see it here, you mean? Yeah, that is pretty cool. And where I am, I'm in Connecticut, and the telescope here is out in the Sonoran Desert in Arizona. So I open the roof and start up the telescope from here and run it from here, which is kind of cool. I mean, I guess, I don't know, call me weird, but I just find it really fascinating that I could be running a telescope 2,500 miles away from here. It's just so cool.
You
Izabela
look like
says,
you're missing one of your images.
what do you mean?
Over on the left, beneath where that shows the telescope.
Oh,
Didn't
yeah,
you
yeah,
used
yeah.
to have two views?
Yeah, I do. And what's going on there is, let's go show you. If I bring that up, I believe that image, the connection has failed on that camera. It's intermittent, so I've left it out for now. And that's okay because it doesn't muddy the water here. I just need that one view just to make sure that things are well. It was up earlier and then it goes away. I don't know. So, yeah.
Is that our Terra D is here?
Oh yeah, Terra D. Oh, look at that. That might be Terra. Terra, is that you? Terra D? Terra Diulis? Yeah, we when we did the radio show earlier, Terra was just so on the ball. I don't know if that's her, but if it is, that's great. But it reminds me, she was on the ball. She had so much to add to the show. It was great, and I really enjoyed that. So I was very grateful that she can join us and help us. Yeah, I think that's her. And Papa Tom, what's going on, man? You're in northern Minnesota and you can see it too, huh? Wow. Sean, what's up? Sean Newpower's here, and he says, I swear I just saw a meteor on the scope live view. If you saw this thing here, that was a satellite that came through. But guess what? A meteor might make a little bit more of a line that's a little bit more broad, maybe get a little thinner at times, because we can't gauge across the field. We don't know whether the meteor's burning up at a different rate as it crosses the field. I've had a meteor go through, but we're just having, as we're stacking here and stacking images, we're up to 25 now. This set of images is getting clearer and clearer, as you can see, and the noise is really abating well, and this is going to be an example. Look at that. This is looking nice. And there's a little orange here, so there's a little bit of sunlight still infecting our view, but we're getting close. And all I had to do was I do a color correction, and here, what you see in here, there's a red, green, and blue curve. And if you were to mess with these a little bit, you'll see how you can move the red curve. All right, you can move the green curve. All right, so the green curve is here, the red curve is here, and then you have the blue curve, right, which is now right here. Okay, and I'm just tweaking it over there. So your image can take up a lot of different views. But if you come in here now, you align all these. Now what you're doing is you're aligning your image so that all the red, green, and blue is lined up, and then you get a perfectly rendered color image. And that's what we're trying to do with this. And so with SkyTour Benson, we'll be able to take shots like this because the filter has 5 positions. And in those 5 positions, we're going to have a filter exactly the same as the one we use to keep these, to take these images. Okay, that's called a UHC-S filter, and that's kind of a narrow band filter all in one. So it's got 3 slots of light that it allows through. the light for the hydrogen alpha, the light for the oxygen 3, and the light for the sulfur 2, and perhaps H beta. And so that will be used as well. And then in one of the slots, we're going to have, or the other 3, we're going to have the narrowband filters for H alpha, silicon, sulfur 2, and O3, oxygen 3. And then in the last slot, we have a spectral dispersion filter, so we'll be able to see the spectra of the stars. And when we look at some of these stars, we'll be able to look at the spectrum and see the absorption lines in the stars and be able to identify different features. When you look at a nebula, you'll see emission lines from like the Orion Nebula or other nebulae out there. You'll see these emission lines. Those are really cool. And that's already in the filter. I've already tested it. I already know it works. So we're going to have a good time. And I think that's really cool. Tara says, "It's me. I am what I am." Ooh, that's Popeye. So hello, Tara. Thank you for joining us tonight. I think we have 36 of the 15-second shots. Let me darken our background, guys, just a little bit. Come over the top of the hump just a bit. Darken it up. Okay, there we go. And then move this at this end down just a little. Soften up any remaining noise. See how that looks. Give it a second to come in. And clear. See where there's lots of data, you see that it's much softer. Here, we need to go longer to catch the rest of this detail out here. But I can also just pull this back a little bit. So our processing will take care of managing all this, and we'll do that. Now in Photoshop, as Izabela knows, because she does a lot of the photo processing with me, I've written some actions which allow us, they're called action sets, and they allow us to do some immediate work to shortcut all the longhand stuff you've got to do final processing on these images. And that's pretty cool. So, okay, we got 41 done. I think we're good here. I'm going to save it. Now, for those who have just joined us, one thing you guys might want to understand to do is go here. Go to skytourlive.org. See it over my head? skytourlive.org. And as you scroll down, you'll see a section that says, take me to cool images. And it's going to, and read the instructions. It's going to take you to our server where you'll download this image just like you see it here. Okay. And you'll get this image. In fact, I'll show you the actual image you're going to get. And it's free. You can download it. There it is. That's what you're going to get. Right there. This image. Okay. And then you could be free. You feel free to like zoom in on it and do work on it, study it, what you want to do, put it on your desktop, however you want. And the image is free. All right. So all of our images we take, they're free. And then if you want to join our Patreon, what we will do is you can get the much more finished processed images. Our Patreon levels are for everybody. We have a Patreon level for everybody. We need support, because each location, we have one location now in the Sonoran Desert, the second location in Benson. That's going to require internet connection, and that's a monthly cost that we can't avoid. We're using Starlink for that. Then we're going to have an internet connection out here in SkyTour East, and that's a dedicated East Coast connection. That's all it's for. And so we're going to need it for that too, and that's going to be for the solar observatory that we're putting in. And Izabela's asking me to do something. I got to listen to her, guys. If I don't listen to her, I'll get in trouble. She says, "Mark, can you please tell people that the database is now complete?" Oh, okay. Yes. Thank you, Izabela, for that reminder. Okay, here's the thing. We've captured data from 2021 to 2024. All the streams, all the data, all the images are all up in a database now, and they're in those folders. And so what you can do is you can go through by hand and try and figure out where we looked at the Orion Nebula, or say this, Measure 81. Or you can look in our database, and we provide you the ability, we're providing, it's not quite finished yet, but we will be providing you with the ability to search our data and say, show me all the times we looked at Measure 81. And you'll get a big list of all the times. And then you can go there, okay, and click on the different links and capture the images and bring them down. Why would we do that? Well, let's suppose we take a look at these galaxies, and then a year from now, a supernova occurs. And then a year after that, it's not there anymore. Well, if it gets missed officially, and that does happen quite a lot, then guess what? We can find it. Because you'll be, in fact, if you find it, you'll be the one that gets credited with the discovery. So our data is a working data set. It allows you to make beautiful discoveries. I'll give you an example. Izabela went back and studied a number of our Pleiades shots. And in one of those sets of shots, there was a star that wasn't there before. And what it turned out to be was an asteroid. And she's actually found an asteroid in another set of shots as well, because we take shots of the same thing over and over many times, and we do that not because we don't have any others to take, but because we need an ongoing record of all these objects out there, and this will give us an idea, and as Daryl knows, to do work in astronomy, you have to do repetitive photos of the same thing and look for changes, and that's what we're doing. Izabela's found changes. Just in the data we've got since 2021. She'd be a superstar, Daryl.
Oh, yeah.
Yeah. Okay, we're going to say this one more time.
Izabela's going to be running this place one of these days.
I know, that's why I said I got to do what she says or I'll get in trouble. And she says there's different ways to search, and there's a help section. Yeah. And look at this. Yesterday, she found one very cool asteroid. Now, see, so that's what happens when you point a telescope at the sky, folks. You will end up finding things that you didn't realize are there. And that's what this is all about. Free bird Izabela. Okay, let me zoom out of this now a little bit. Okay, so there's another galaxy here, okay, that you can see. This glow over here, this is called amplifier noise. And we get rid of that. But this galaxy is in the sky with this. Look at the beauty of this. Yeah, let's try something one more time. I'm going to actually increase the value of the sharpening on this to see if we can capture any more detail. Oh, look at that. See, there's a lot of detail here. This here, look at that line. That line is a bunch of young hot stars in this galaxy. You can see the swirls and the feathered edges of these spiral arms. Ah, that's incredible. Absolutely incredible. Jeez, it's like I don't want to leave, but I know we have to. Okay. All right, Daryl, you had something you wanted to see before, so why don't we check that out? So this is saved, by the way, and now this is going up to the database right there. Within 30 seconds, it'll be up there, and to get there, you go to skytourlive.org, scroll down, take me to cool pictures, read the instructions, and you'll see the directory for Measure 81 for tonight's date. All right, so feel free to do that. You might want to wait till after the stream, or you're going to miss some stuff. Anyway, there we go. So let's go back now to 1 second here, and then we can look at our nice view. This is good. All right, and I'll go down to 25%. There we go. So this is the whole frame right there. All right, bring up our planetarium. And where do you want to go? Oh, I guess from here we could go to M51, huh?
Sure.
Right? I think we can. It's nearby. I'll skip M82 for tonight. M51. that's nearby. All right. So we're going to go here. What's here? This is another galaxy, but this one is interacting with another galaxy nearby. You can see the star streaks as the telescope is moving through, and you'll see a fuzzy object appear in here in a moment. It's up there. There it is. Okay, so we'll bring that down into the field a little more. Okay, that is another galaxy. It is galaxy season, as we said. So let's bring it down into our view a little better. There we are. I just can't get over that I'm doing this from all the way across the country. This is just so cool. Alright, so now we'll go a little westward. Swing the telescope that way. Heading westward, center it up. There we go. We'll set up our exposure over here. Then I'm going to show you, and the new folks show you the basics of this whole setup while we're waiting. This will be a 25-second exposure, right? And we'll move over just one more bit. Now what happens is every time we center up and we get this thing ready to go, it doesn't have to be in the center, but this is good enough. The telescope finds a guide star, and it proceeds to guide, and you're going to see it says searching up there. It's searching for a guide star. When this actually goes to numbers, it's found one. Okay, so it takes about 11 seconds, and there you go. It started the guide already. So what we can do is take our 25-second shot and say, go for it. And then we'll reduce the brightness and come down to our live stack again. We'll see the last thing we took. There it is, Measure 81. That's in there. That's beautiful. That's up on the database already, probably. And we'll clear this. And now we'll check out the Whirlpool Galaxy. Why is it called the Whirlpool? Well, there's a reason, and that reason will become clear in a moment. And that reason has to do with the fact that it looks like a little whirlpool. Okay, it's just an elegant galaxy, and it's face-on. It's a face-on spiral. And this is another galaxy that has passed through it. And you see the spiral arms. From the side, this galaxy looks like this. The spiral arm has been dragged down, and the satellite galaxy is a little further away down here. So it's passed through, and as it passed through, its gravity is tugged and pulled this spiral arm a little bit away. We'll zoom in a little bit away from the galaxy, and it's also angled downward just a little bit, which is kind of cool. Neat stuff. And let's darken this up here, Daryl. Okay. All right. While that's coming in, let me just give you guys a little bit of a primer for those that are just joining us and haven't been here before. This will be quick. This over here, this is the telescope control section. This is the guiding and the telescope computer. This is the telescope out in the building. This is the big mouth that's doing all the talking all the time, and I'm sorry about that, but that's just who I am. This is our stack screen down here. Okay, this stack screen is the one that's going to show us all the images that we're stacking on top to make the image sandwich. Over here, this is the most important field on the entire telescope screen. This is the camera control. That's the exposure control. The next most important one is the gain. This is how sensitive the chip that records the data is being set to. So for a 25-second exposure, our gain is set to 250, and that gives us the amazing sensitivity, and it's a balance between sensitivity and exposure. The lower the sensitivity, the less noisy, grainy stuff we have, but the less detail you'll see. Okay. The last thing is that this down here is the focus right here. not that. This is the focus section right here. So this will allow us to focus. This is our histogram. It allows us to make the screen momentarily brighter and bring in a little more data. So that's a quick perusal, right? If we hit that histogram, make it go bigger, it kind of shows us all the data that's here. And now you can see there's some other fuzzy data out here around this satellite galaxy. But, you know, we also get noise with that, so we keep the noise out. There's a satellite that's starting through. You also may have noticed some new music. I have some new music. Look at that.
That's nice.
It is, isn't it? This is never a disappointment, Daryl. I'm telling you. Fantasy says Whirlpool is cool. Mr. Django says I love this one. Yeah, we do. Michael Hedrick says gorgeous. Yep, it sure is. Yeah, and we got a satellite that's tracking through here. This is not a Starlink. A Starlink would be a longer trail. Wow, this is neat. So let's zoom in on this a little bit, Daryl. Catch it a little more detail. Look at that. That's something. That's a beautiful galaxy. Whenever you have a face-on galaxy like this, you can see all the detail. Look at this arm right here. Look at this little tortuous, flow in it, like right here. This is really interesting how that little winding goes like this. You see that, Daryl? This guy right here, this winding.
Yes.
Yeah, that's something else. And it's got a bluish cast to it, which is probably because those are young hot stars in there, and the star birth that's occurred in there is probably due to this galaxy interacting with the entire bigger galaxy here.
Yeah, there's a kink in that spiral arm.
This one?
Yes.
Yeah.
Right there you can see where it looks like it's been tugging.
Yeah, that way, yeah.
That whole area toward it. And
that's right.
Other places in the galaxy.
Here is a definitive warp in this spiral arm right here. Right there. See how that comes down and it cuts right over? This has a straight line here that's like a tug that way. And there's that weird kink, and then this is the point Daryl's talking about right here, where the galaxy's spiral arm is being pulled by this guy, which is actually further into the page, as I said. And from the side, that galaxy's spiral, this galaxy's spiral arm here, is a set of spiral arms is curled downward like this. So from the top, it looks perfectly flat, okay, but from the side, it's curled down at this end over here. So that's pretty cool.
I think we've talked about this before. How might the satellite galaxy have passed the big galaxy? I know I see details over at about 10 o'clock. There's a patch between the two spiral arms.
Yeah.
And down at 6 o'clock, well, from about 4 or 5 o'clock all the way past 6 o'clock from the center of the big galaxy, the large, hazy, extended area.
This guy? Or this?
That.
Yeah.
That I almost wonder, the satellite didn't come in from the lower left or something and sort of distort the spiral arm on the bottom.
Yeah.
Then as it passed by, it started distorting all the stuff on the upper left-hand side.
Well, if we look at the radial velocity studies for these spiral arms, we can see which way the arms are moving and which way they're going, and that's why we know this arm here is going away from us, because we could see that it's been shifted. Its radial velocity of that arm has shifted it downward, so it's moving away from us. So it's more red shifted. Blue shifted is coming towards you. Red shift's going away. So that's what we will see. It's really neat. So we got 18 exposures here at 25 seconds. See right there, it says 18 exposures. None have been rejected. It's a very calm night out there. So we're really liking that. Let me just back this a tiny bit out off that curve. I don't usually go to the peak of the curve because I want to kind of allow some of the light to come in from the faintest areas to show us the detail. I mean, if you push this, you can really see there's a lot of stuff in there.
Can you zoom in just a hair more?
Yeah. Let me just set this back to what I want.
There's a lot of faint stuff showing up around the satellite too.
Yeah, I see that.
Pretty extended.
Yeah. It is almost overhead, so look at that. You can see the dark nebula in here. Now, this dark stuff could very well have come from the original galaxy here, or it could have come from part of this spiral arm. We're not sure, but I guess a study would actually show that. Dean Bostador, how are you?
There's a pretty pronounced small dark area just to the upper left of the very nucleus of the big galaxy.
This here?
That right there.
That curve?
Or
just this? Or this?
Just that right on the dark area right there where your pointer is.
Okay. Yeah. So what we're going to do, guys, Sky Tour Sonoran is going to be looking at the wide field view, like I said, and Sky Tour Benson is going to be looking at a much more magnified view. So we're going to show this, as an example, this galaxy, like you see it here, in the wide view. And then we're going to flip over to Sky Tour Benson when it's up and running and show you what Sky Tour Benson's seeing, because we're going to have the telescopes going to the same objects each. And then we're going to be going back and forth so you can see the differences. I think that's going to be very helpful and worthwhile. You know? And because Sky Tour Benson is 150 miles away from Sky Tour Sonoran, we're going to be able to take images of the moon and manufacture, I think, a 3D image of the moon. No one's ever done that. You see the moon from a slightly different angle, slightly different position, and you can make a 3D image of the moon. And I think 150 miles is just about right to get a reasonable 3D model, or 3D image of the moon. So we're going to try that too. We guarantee we're going to try that, because it's going to be a little bit different. It's not going to look exactly the same, because we're moving across a curved planet, and we'll be looking at it from a slightly different perspective.
Mark, will you excuse me a moment, please?
I will indeed.
Right back.
Okay. So there we go. Izabela says, don't the telescopes need to be exactly the same to make it 3D? The images have to be exactly the same, Izabela. So if the image scale is much bigger for one telescope versus the other, we just change the other to meet the other image scale. And then we can make it 3D from there. So we just have to make sure that we, and I'll make up a word here, identicalize it. We have to just make it, and that's something that we can program into Photoshop, actually. We can have Photoshop set the size automatically of the images so that they're matched, and then we can do 3D. No, it wouldn't work on things like galaxies because they're so far away that even even if we used the entire Earth orbit to try and do it, it wouldn't make any difference because they're just too far away. So the distance from one side of the Earth's orbit to the other would make absolutely no difference in trying to make a 3D model, a 3D image. So that wouldn't work. Yeah, so that's pretty cool. All right, and if you can, as you can see, the sky is really pretty tonight. It's got a lot of beneficial. This is gonna be a little brighter. Look at that! Wow. Let's pull this in. Now, you say, well, can you get rid of some of this noise? Yeah, the 250 gain that we're using here, that's high. You know, the ideal gain for this particular camera is 100. So I will name this the Whirlpool Measure 51 M51. Oops, sorry, that's M52. M51 Whirlpool Galaxy. It says Whirlpools, it's misspelling. Excuse me. Let me get rid of that. Okay. Alright. So I'll save it. Oh, that's not what I want. I had an extra character in there. So we'll save it.
Okay.
Alright, good. And then we'll save exactly the scene.
We're seeing a ton of extended nebulosity tonight up there around
I
the.
know. It's beautiful, isn't it?
It's like there's a branch kind of hooking up to the right from the lower right of the satellite.
Yeah, and I think we can process a little more out. Yeah. Look at all that stuff. Steve Tuttle, welcome. And Steve has a question. He says, is it proper to say that the top galaxy is rotating clockwise and the larger galaxy is rotating counterclockwise? Well, if you want to think of it, it's actually that the bigger galaxy, the main galaxy, is rotating counterclockwise. Okay. So yes. And that it's the arms are dragged out by differential rotation, right? A little bit slower on the outside, a little bit faster on the inside, and there's an issue with that. It's something that has been a cosmological conundrum for quite a while. I'll tell you about in a sec. This galaxy, however, we don't know, Steve, which way it may be rotating. It looks like you see a rotation here, but this might be a spiral arm from this galaxy that's been dragged into it. So I don't know what the rotation data is for the smaller satellite. Okay, this one we know now that this one is rotating in this direction. Okay, now because this galaxy has been there for a long time, it at the time that we're looking at this, okay, 13.8 billion years into the universe existence, and this galaxy was probably formed relatively early on. These spiral arms should have wound up by now, okay, because the galaxy's been rotating. For instance, our galaxy has gone around almost 20 times, and rotated 20 times since the Earth was formed. And that's not when the galaxy was formed. The galaxy may have been formed before that. So how come the spiral arms don't wind up in that amount of time? And that's where the concept of dark matter comes in. There seems to be a halo of material around galaxies that make it spin more like a solid disk than a true differentially rotating thing. So that's what that's one of the current thinking is right now. Okay. And Izabela is saying, why are the RA and dec numbers changing on the left? These are the right ascension and declination numbers. Well, they're actually, if you notice, they're really not, but the altitude and azimuth do, because the altitude is changing every second, and the azimuth is changing. The altitude is the height, and the azimuth is the angle off of the North Pole. So that is changing every second. But the right ascension and declination, they stay pretty constant. They may change slightly, and that's due to inconsistencies with the way the encoders in the telescope are reporting. But they don't go very, very much. They don't change in more than just the seconds. And they go from like 37 to 38, okay, and then go back to 37. So that's the constant number. Now, Michael Hedrick says, Mark, how many years would these galaxies take to be in this state? Least amount of time. Well, hard to say, Michael. It depends on the velocity of the galaxies toward each other and through each other. But these galaxies could have interacted starting 2 million years ago or 30 million years ago. You know, it depends on how fast they've been moving. So we can't really know that for sure unless we get an idea of how fast the satellite was moving relative to the main. Now here's another wrinkle for you. This satellite galaxy may have, this is one thought process, caused the spiral arms in this bigger galaxy. Now that is due to the disruption of the way the arms are going. There might have been some very tight arms, maybe very loose, not sure. But there may have been fewer arms. This galaxy passing through could have induced formation of more spiral arms. That's actually an ongoing thought problem that has been passed around in the astrophysics channels. And that's very possible. So that's kind of a interesting development with the whirlpool, is that the spiral arms may not have always been there. And this satellite galaxy made that happen. Okay. All right, and now what I'm going to do is save it. Okay. So this saves the raw file, the raw astronomical FITS file format. So all data is preserved. And then we save exactly as seen, and you'll see it just like this. Okay. So now I'm going to try something else. We're going to clear this one again, but now I'm going to drop this down to the sensitivity that it wants. 100 is the best sensitivity for this particular camera telescope combination. So we've cleared this, and we're going to try it again. And this next one I'm going to clear because it's going to be a mix of both sensitivities. Alright, so now we'll see. Oh, thank you, Daryl, for putting up the image landing spot.
Oh.
So now we got the sensitivity to 100. I'm going to show you the difference. You saw that noise in the image, right? This one will produce less noise. And we might get more detail overall, but we got to check. With bright objects like this galaxy, we can do this kind of thing. I would predict, though, that when we take an image of this lower sensitivity, that these fuzzy things out here won't be as visible. That's my guess.
Say what?
The fuzzy stuff on the outside here won't be as visible now in this, because we dropped it from 250 to 100 in sensitivity in the gain.
Oh.
So you can see how the tail here going into this galaxy is almost not visible. But why would you do this? Well, several reasons. You could take the images that we created from the last one and use the images from this one to help includes some additional data or details that were washed out by the other one. So that's usually why we take these like this. But we don't do this every shot. But the nucleus gets very washed out really quickly, and so when we take a shot for 25 seconds at a lower sensitivity, not as much light comes in to blow out the nucleus, and now you can actually see that. The nucleus here is not just a big white blob, it's actually less. This one is orangey, and this one is whitish blue. Whitish yellow, I should say.
The wiki for M51 says the satellite may have passed through the main disk of M51 about 500 to 600 million years ago.
Okay, that's right again. So that's the speed of approach is going to determine all of that. So you're thank you for looking that up. Yeah, so I think I have the enhancement set to remove color noise. Yep. Alright, it'll normalize here in a second. Very cool. So by playing with these settings, you can get more detail out of it, you know. So I'm not going to be saving this one. I just want you to see what I did here so you can get an idea. But you notice how the wispy structure that Daryl was talking about before, you can only see a little bit of it on here. And that's because our sensitivity is down. All right. Now, I think I'd want to do is, while we're waiting for that to come in, I'd like to see if we can look for another one. Now, we have another galaxy over here. Is this the one? Yeah, the sunflower. Shall we check out the sunflower?
Sure.
Yeah. Okay. So I won't be saving this, but I wanted to show you that. Let's go up to. Sorry, I want to actually jump up to 200 instead of 250.
Gene Bostador has a question.
Okay.
Could the top galaxy have been actually larger than the bottom? It's considered a satellite, Dean, so I don't think so.
Yeah, what
that
Daryl
is
said is
the
true.
top galaxy is a satellite.
Yeah. All right, let's. That's actually a very, very good question, Dean. Thank you for asking that. C&D boy, hey, thanks, man. I'm glad you enjoyed it. Okay, so let's now take a look at another object. And to get there, we are going to go to our 1 second interval here. All right.
Did you say Messier 63?
Sunflower Galaxy, yeah. Okay, and so there it is there. And now we say go to it. And now you'll see the star streak and you'll see our crosshair go there. Boom. There we are. And the Sunflower Galaxy will be in our view momentarily. I gotta drop our. There it is. Okay. The Sunflower Galaxy is really pretty because it has this gorgeous set of spiral arms They're relatively tightly wound, and just stunning. It is just absolutely beautiful. So I'm looking forward to showing this to you, as I'm sure Daryl is as well.
Sure.
Okay. All right. So in the time while we're waiting, it's going to be searching for the. It's going to be searching for our guide star. Hi, Ricky Ricardo. How you doing, man? Hey, Rascally. And Claudio Ramos from Chile. Hello, hello. Nice to see you. Thank you for coming in. Curtis Horn, how you doing, brother? Good to see you. Curtis, you're going to be a contact? I know I asked you this last time. Contact in the Desert, May 30th to June 2nd. I'll be doing the, in part, I'm going to be doing a live stream live with a studio audience, which is great. I'm also going to be doing 2 more lectures. One of them is going to be, both my SkyTour live stream lecture and my workshop and my intensive, they're called. Those people have to buy tickets for, but everybody's doing that for the different talks. But we're giving away equipment during that time. And so we're going to be giving away binoculars and telescopes to people who, the lucky people who are selected in our talks. And I think you guys are going to enjoy it. Okay, we're going to give away Celestron binoculars and a Celestron telescope to get people on their way. Yeah, you're in Chile, Claudio. Nice to see you. Okay, now that we got our guide star, let's go up to, we'll do a 25-second shot here. I dropped the sensitivity to 200, reduced the grain and that noise just a little bit. And then we're going to stack this. You'll see the previous thing, I think. Oh, no, actually, when I do this and get rid of that, it'll go away. All right. Now, we have to start later because of the fact that it's as the summer approaches, it doesn't get dark till 9:30, right? So we have to worry about that. Okay, so our colors are pretty well lined up. A little bit of change. Okay, and then we can adjust our levels to make it look right. Okay, and we'll pull this down, the mid-range guy, a little bit. Yeah. Ricky, it's okay, man. Thank you for hanging with us. We appreciate you being here. Oh, Rascally, I'm glad you listened to the Neutron Star thing. On SkyTour Radio tonight, we talked about neutronization, which is, when you think about it, why does a star become a white dwarf, and then how could it become a neutron star? Because you hear the term neutron star, and you hear, oh, well, okay, it's a neutron star. That means that most of what we see on this star, the composition, is neutrons. Well, how can that possibly be? And it's through a process called neutronization, meaning that more massive stars will make more isotopes of elements. Now, they're only nuclei. Okay, so you have protons and electrons running around loose, right? Because nothing, an atom can't survive in that kind of hellfire in the middle of a star's core. So this is beautiful. I'm going to zoom in. So what happens is the protons and electrons actually combine and make new neutrons. So a proton plus an electron will yield a neutron plus, I believe, an electron neutrino. and so it releases some energy. But when this happens, the stars that are heavier tend to have a lot more neutrons as isotopes, and so the protons and those electrons can combine and make more neutrons in addition. So the larger stars tend to make lots of neutrons, and so when they collapse, they go right past the white dwarf thing and they go right to neutron stars. The reason is because for white dwarfs, those protons and electrons, the electrons are not bound up with protons into anything. They're just free. And that's because there's not enough pressure, not enough temperature to really cause the protons and electrons to combine into neutrons. So it's like a checkerboard. You have an electron in each checkerboard location, and once that checkerboard's full, the electrons resist being crushed further, and that works for stars that aren't as massive. Okay, like the sun isn't as massive, so the sun will always end up, in its end, will always be a white dwarf when it dies. And so when you look at the white dwarf concept, the electrons are holding the star up. Okay, and that's called electron degeneracy pressure, and that they push out. But if you have a more massive star, then those electrons that might hold the star up are combined with protons to make neutrons, and so now the proton plus a neutron or electron makes neutrons. So you don't have a tremendous quantity of electrons, you have a lot of neutrons, and these neutrons, again, in the checkerboard, once they fill each checkerboard square, okay, they resist being compressed any further, and for a certain size, up to a certain size, like 2.4 to 2.6 or so solar masses, those neutrons can resist being compressed and crushed, and that will leave a neutron star. Okay, and beyond those high masses, then the neutrons continue to get compressed, and you end up with a black hole, because now, in addition to the high compression, you've also got deep space curvature, the space-time curvature, which is just immense. And so when that happens, the light follows the curve of space. It doesn't have mass, so it doesn't get affected by gravity. All right, but space can be bent, and that's what's affected by gravitational forces. So you have a deep, like a star. As a light beam goes past the star, it'll bend a little bit. We noticed that, and it kind of proves relativity by looking at stars around the sun during an eclipse. Okay, we saw that experiment's been done a number of times. Now, that said, when you actually look at a black hole, now the curve can be so deep in space-time, the space-time fabric, so to speak, that light is going to curve around that black hole immensely. And when it does that immense curve, what will end up happening is, if it goes too close to the black hole, it could end up going past a magical point where it can no longer get out, because it's following the curve of space. And if the curve is so deep, you might find that it's curving around on itself over and over and over, and thus a photon of light can no longer escape the black hole. And that point is called the event horizon in a black hole. And we can, based on a number of particles, number of things that are in the black hole, the mass, we can tell you how big it is, what its radius is. And that's called the Schwarzschild radius. And that value is something you can calculate. So, the concept is, they used to say, right, and Daryl, you've heard this before, there's a singularity inside a black hole, right? That's what people say. Supposedly, but that, in reality, none of us believe there's actually a single infinitely small point in there that everything is crushed to. That's not what we think. What we really think is that the black hole can grow if mass goes into it, and that's true. So all this massive condensed material inside can be so can so deeply bend space-time that light can actually end up getting trapped in there. All right. So the reason we talk about a singularity is for the same reason we talk about in physics, like the center of the Earth and the center of the Moon, and we calculate gravity based on the center of each object. It's a mathematical construct to make it easy to discuss equations and to discuss gravitational forces with a black hole, with the Earth and Moon combination, or any other massive gravitational body. And that's what we mean by a singularity. No one believes that there's an infinitely small point inside a black hole, all right, that has all the mass compressed into it, because if that was true, then a black hole could never grow, but a black hole does grow. The black hole in Messier 87 is actually the size of 5 to 6 solar systems in diameter. That's huge. And so because it's so huge, it's got a lot of mass in it. And so that mass is also very highly compressed. So it deeply, deeply curves space. And so beyond a certain point, its event horizon is way far out from that mathematical singularity point in the center. Right? And that's where light cannot escape from on there. So that's what we mean by when we talk about singularities. All right, in a black hole. If you have any questions about that, ask Daryl. He knows it too. I'm kidding, you can ask both of us. Look at that, Daryl. Sunflower looks really nice, huh?
Uh-huh.
Wow.
Have you focused tonight?
I did.
Okay.
Look at the bar across this galaxy. That's a wild looking. You can actually see the dust lane. This galaxy is not quite edge on. So if we get ourselves in here and move in, the galaxy we're looking at is up here. So we don't see it because we don't have that catalog selected. Let's do that. Let's do ARP and Melamed. That's usually clusters, and we'll do these anyway. Vandenberg, Sharpless, and let's see if that brings us in. No, so that must be a different catalog. It could be Abel, huh? An Abel catalog object. Let's see where those are. Where is Abel?
Go 4 rows to the right, bottom one.
Oh, there it is. Hello. Okay, let's see if that brought in. Didn't. So that galaxy, it's probably listed in here, but we just haven't. It's probably going to be considered one of these other I just probably just, why not just do this and this one too and this one, because it's going to be a faint one. Did you see that object just fly through? Something flew through there. It's a moth. They can see the infrared. Oh, it could be a Caldwell object. I didn't see that. I forgot about that. Let's find out. Ah, now we're talking. So this. Oh, it's the PGC. Well, it's that's 7, so that's strange. Well, let's see if that's the galaxy. Well, it's that guy right there. So we have the disk of the galaxy, and it's up from the disk. So let's go back. Up from the disk. Could be this guy. Yeah, that could be. That's a spiral. I have to look what the M means. That is actually kind of too close, so let's go back to like 25%. Oh yeah. Okay. So there's one there and there's one there. So let's figure out which one those are. Which ones those are. So this is where we are. So we have a galaxy here. An active galaxy.
Actually, I think that
might be this one.
The one you were just on, I suspect, is it, actually.
You think this is this one?
Yeah, yes.
Let's go see. Yeah.
I need that red star that Steve was asking about.
This one?
Yes.
Okay, why don't we do that?
Because that's actually in Stellarium. That's it, right? It's to the left, not to the right.
Oh, wait a minute. I'm upside down. My mistake, guys.
Yeah.
If you look at the yeah. Okay, yeah. All right, so this galaxy right here, this is that active galaxy. That's this guy over here, right? This one?
Oh.
Okay, yeah. I was upside down. My mistake. And then this one is the one that's actually on this side over here. That's this guy right here. Yep.
And that bright red star is that one right there.
This one?
No.
No.
To the left.
Right there?
That one. I suspect.
No, that's just an SAO. It looks like a star that's white. It might be. Are we out? Maybe it's this one. That's a G5. Yeah. Okay. Let's see here. All right. So that's the star we were talking about that was in the galaxy. So that star right there has got a double, not double, but looks a visual double kind of a thing. All right, so let's go back. And let's see now. And one more time, sorry. So it's just up and to the right. Okay, so up and to the right is up and to the right. So this looks like it could be the star, like you said. And it's within the range of these other galaxies too. But this star, what star is that?
That's much farther out.
Yeah, that's not in our view, I don't believe. All right, so interesting. All right, well, this is a good capture right here. Let's see if we can. Oh, look at that. That's nice. Well, that's pretty.
Excuse me.
That's beautiful. All right, so we can work with that. Excellent. So there's 37 of them. We're going to save this after I make a note of it. This is the Sunflower Galaxy. Okay, and we will save it. Save it exactly as seen. All right.
You got two more Messier galaxies in Canada's Medici, M94 and M106.
I'd like to see the Pinwheel.
Pinwheel.
Right?
M101?
Yeah, isn't that nearby too?
It's on the other side of the handle of the Big Dipper. It's not in Canada's Medici.
Yeah, I know. I want to.
Sure, yeah. I mean, it's yeah, that's it right there.
Yeah. Okay, let's go to the Pinwheel because this one's really pretty. It's another face-on spiral like the Whirlpool. And let's go.
See, it almost makes an equilateral triangle with
These guys.
Mizar and Alcade.
Yeah. Okay, well, we're moving now to the Pinwheel. And we should see the Pinwheel show up in here. Let's drop our size down here. There it is right there. Okay, so now we'll drop it down. As you move them down, you can actually see the fuzz easier. Galaxies tend to be low surface brightness sometimes, especially if they're galaxies like this one, which are broad spirals. Okay, we're going to center this up. And we're going to do this. And we're going to move the telescope down a bit. And go west a little bit. Center it up. Hey Lubo, how are you? Did we not do a target that you asked for, Lubo? If we didn't, it's only because we missed it. Not that we wouldn't have intentionally not gone there. But let me know what you're thinking of, and if it's something we can go to, we will. Okay, so we're here. So what I'm going to do now is synchronize on that. There we go. Okay. This should be a fairly big object, so let's give this a good going over. We'll do 25 seconds. And we've got our guide stars. We're guiding. Let's do it. Off we go. Let's
leave your gain on 200 still?
Yeah. Thank you. 6543 Lubo wants to go to. Well, where is 6543, Daryl? You want to look that up for me?
Oh, the cat's eye.
Where is that from here? Can we see that?
It's in Draco, I believe. Yes, Draco.
All right, look how nice and big this galaxy is, guys. This is going to be a really pretty scene. Very pretty. Yeah. Very pretty. Let's get our curves marked and then okay. What's the altitude of it? Do you know?
Not yet.
Okay. We can figure it out because look at that. This is going to be really pretty, guys. Wow. And this is Measure 101. It's galaxy season. Pinwheel Galaxy. Lubo, if it's high enough, we will look at it. And I'm happy to go there if we can. Izabela is correct. The supernova is no longer visible. Remember we checked out the supernova here?
Yes.
It was like right here. Right there. It is no longer there. It has faded.
It may be too early for the cat's eye. Cat's eye is in Draco, but it's over in the lower part of Draco presently, lower in the northeastern sky. It's quite a ways below where we are.
Okay. Lubo, that's later on in the season when we get into the summer constellations. The cat's eye will be up and visible. And we will check it out for you. We can't go there unless it's high enough to see. Isabel, thank you for putting up the sunflower. What a beautiful galaxy this is. Now, I often think, when you look at a galaxy like this one, right, Measure 101, you gotta wonder, this galaxy is like 21 million light years away, roughly, right? And so you're seeing it as it was 21 million years ago. So you think, what was going on the Earth 21 million years ago? And that's when the light that we're seeing now, right this minute, left this galaxy. Isn't that crazy to think that? And then, on top of that, when you look at a galaxy like this one, and you think about, it looks relatively stable. It looks like things are developing in that galaxy without any kind of tumultuous events. You can see, for instance, nice, fairly well-defined spiral arms. You don't see any accidental starburst stuff. You don't see any kind of tortured spiral arms that are actually being really, really ripped out of place, meaning that there was some kind of gravitational interaction. I mean, this arm, it has a kind of a weird angle in it, and it's possible that there was an interaction with maybe a galaxy or two elsewhere, but it didn't cause any major damage to the galaxy. So what I think is, if you look, this galaxy could very well be a new harbor for life. These island universes, there's nothing between here and there. There's nothing between here and there except neutral hydrogen gas and some oxygen in the intergalactic realm. It's in the galaxies where all the action is. So that's pretty cool.
Can you zoom in a little more?
Yeah. Wow, look at this here. Let's do this.
The supernova was
Wasn't it here? Or was it here?
I think it was just to the lower right of that dot you're circling.
down here or was it up here? You remember?
I think it was to the lower right.
Okay. Well, it may still be visible then, but it might be fainter. So it could have been this one or that one, maybe. Izabela would know because she's been studying these. Lubo says Messier 33 nebulosity is incredibly beautiful. It is. And there's, interestingly, because it's so relatively close to us, we can see many different objects that have been named within the galaxy. Yeah, you'll notice this here is a remarkable green color. So what I'm talking about is this guy right here. That's a green object. We have another galaxy over here, another galaxy over here, and probably more if we back out, you know. But the point being, this green object is interesting because for us, that green object means a potential supernova remnant in this galaxy. Most likely it's in this galaxy and not in ours. So that's pretty interesting. Let's really punch it. See, that's pretty cool. So our full width half maximum filter, we're staying well below in the 6s and 7s. And so that's good. I have a 7.73 threshold. And this is basically the roundness of the star image. If it gets wind and starts to elongate, this number will jump up to 10 or 11. And you'll see a red bar because it'll be above this dotted line, which I've specified as the threshold. Cool.
I had the image of the supernova from last year. I do not see it there now.
So
it is just that bright object right there you're pointing at. Yeah. That is just a second. That's NGC 5461. And then there's a little bitty dot just to its lower right, and then the supernova was a little farther down to the lower right.
Okay, so the supernova was like in here.
Yes.
Okay. Very good, very good. All right, so this is cool, though. You can see the blue spiral arms. These are young hot stars, and the older stars are yellow stars that are not hot and blue. The hot and blue stars don't last very long. This is probably one of the locations where there was a few that have since gone supernova. This looks a little green too. This might be a supernova remnant. This might be a hot OB association here. O stars and B stars. Interesting how when we look at M101 at length, Darrow, we can start to pick out some potential H2 regions, hydrogen emission regions in here, like Orion nebulas, but in a different galaxy. Okay, let's see here. We drop this way down. Now you can see the arms really clearly.
That brought it out quite a bit, whatever you just did.
Oh, here? Yeah, I dropped the mid-level way down to show the little more detail in the spiral arms and more subtle detail.
Go back where you just were.
Yeah, I will. But I'm saying this is to show the subtle detail. And then here, this region, we're pushing a little, and you can start to see more details here.
Actually, I think you can see the supernova now.
You talking about that guy?
Yep.
I wonder. That'd be cool. So Izabela said you can't see it.
No, it's not. Sorry.
Okay.
I don't think.
Oh, Izabela sent you an image. Or actually, she put a link in there. Yeah, see? Pay attention to Izabela. She says, look at the image I posted, Daryl. Okay. What the hell is that? Oh, hold on, please. I have a strange noise out there.
I'm looking at it, Izabela. Bravo.
Sorry about that. I had an animal banging at my door. Sorry about that. I think
Friend of yours?
well, it might have been my skunk.
Oh.
He comes to visit sometimes, and if I leave the garage door open, he'll walk in while I'm working, and he hangs out, which is fine. I don't bother him. He doesn't bother me. I pet him. You know, he's a wild skunk. But I've always had that kind of weird involvement with creatures. You know, I had a fox come in, a blue jay, bears. I see bears every time I go for a walk. In fact, I opened the door the other day here, and there's a bear standing right at the shipping, right outside my door. I got a video with that guy too. This is looking clearer. This is looking good. So if you look right here, you'll see that the total exposure here is like a 13-minute exposure. So we've done 13 minutes and 45 seconds of exposure on this, and that represents 33 frames. So based on that, you can divide the 33 by 13 minutes 45 seconds, and you'll come to a 25-second frame capture, which is what we see right here. So all the numbers are related to each other. Let's try pulling this in past the peak just to start to focus. Okay, so that's needs more data in there. Okay. Wow. That's a beautiful, beautiful galaxy. Now, let's try something here. if we want to identify that, there might be a way to identify that, and that might be by doing this. We're gonna try and annotate this. Okay. Let's see here. That's better. Okay. So NGC 5477, it's a galaxy of magnitude 13.78. NGC I can't read that. Is it 5471? H2 ionized region? I don't know. It's green. That's not H2. And then you've got other regions in here that are identified. See that? Which is cool. This galaxy has not been identified. So the annotation system in here does not have the ability to know what this is. Interesting. What else is in here? Interesting, huh? So this is an active live annotation. So it's dependent on what we're looking at. And you see M101 is here. Magnitude 7.99. Cool. Let's minimize this. Let's actually save this annotation. So we'll save this annotation. All right, and then we can get rid of it for now. Okay, let me just back out of it. Wow, it's after 1 a.m. already. That's what happens when summer arrives. You can't go as long.
Yep.
Tylenol?
Close, no cigar.
Alright, so this is really pretty. Now we'll save it just like this. Okay, so we've been spending the whole night up in the northern regions. And let's go see what else we might want to see here. By the way, by 3 in the morning, the summer Milky Way is up, and I'm debating whether to stream something, that early. I might do it. I might do it. See, Antares is already on the horizon. Scorpion is rising. So the Milky Way is on its way up. Okay. And over here, this is Omega Centauri right here. That's the most beautiful globular cluster there is. And we can't see it from this building now, but we will be able to see it in Benson. It may fill the entire field in Benson, though. Not sure. All right.
It's as big as the moon in the sky, so unless you got a focal reducer on there, it's liable to fill the field of that C11.
Actually, now that you mention that, we are using a full field focal reducer. So we're going to have our F8 system drop to an F6.
F8.
Yeah, on the C11, I think. That's going to drop down to an F6.
F8. It's an F10 telescope.
Well, is it?
Yeah. Depends on which one you got. One version has an f7 reducer. The base version has an f6.3 reducer.
Okay. Well, we're getting the full field f6.3 reducer.
Black tube.
Yeah.
Okay.
Okay, let's see if we can get to the Virgo cluster here. I think we can. We're going to spin around to the other section of the sky. And then we're going to go here. And we should see the Virgo Galaxy. Here it is. For those that saw our Sky Tour radio tonight, you saw the Virgo Galaxy black hole when we started discussing neutron stars and then the next threshold to black holes. So, I think it's fitting as our last object of the night, we look at the galaxy that actually has that black hole in it. You won't see a black hole, obviously, but you might see the active radio jet coming out around the 2 o'clock location on this galaxy.
Can I make a suggestion?
Yeah.
Up you gain it for 250 again. I think it'll help pull that ray out.
I was thinking that maybe, well, could be right. Could be right. We should try it, I guess, just to be fair. All right, let's do that. I'll up it, but I was worried about it being lost in the noise if I do that. But we'll try it. Easy boy, what's going on? Okay. Good enough. All right. Let's change it to M87 Virgo Galaxy. And let's now go to, we'll say, I'm going to start with 20 seconds on this, because I've found that you don't really have to try too hard to see this. But we'll try it. Okay, we're going to get rid of that. Our last object is gone already. There it is. Okay, let's do this. All right. Get some like that, and now let's just drop this down. I knew we had to do that last time in order to actually see this. The Virgo Galaxy is a giant elliptical galaxy. It's I don't know how many stars it has in it. You might know offhand, Daryl.
Not offhand.
Okay.
But it's huge. It's like maybe a trillion. I forget.
Yeah. The Andromeda Galaxy has over 1 trillion stars in it, they think. So off this, at the 2 o'clock position, and we might have to actually reduce the brightness of the nucleus to see it. So come way down here with this. Yeah. There it is. Right there. I know it doesn't look like much, but this right here is the radio jet. It's a jet of visible matter that also has a strong radio source signal associated with it. Okay, so that thing we're looking at is this guy right here. You see that little guy sticking off of there? That's the jet coming out of Measure 87. We'll back out for a minute because I want to actually do the annotation again and have it do the whole sky, which it will now do. This is previous. And it's going to now do it for here. It just shows the last one. And in a minute, it's going to do that. There we go. So it identifies all the other galaxies in the view. I think this is a really cool thing that this does. Very impressed with it. Okay, Virgo Galaxy, I'm going to save this exactly as seen. Just to get the annotation saved. And then I'll kill that. Let's, as we lose noise, let's zoom in a little more. There's the jet right there. Look at it. See it?
Yep.
That's the jet sticking off Measure 87. Very interesting how that all came to be. At some point, we'll probably discuss that too. Wow.
I mean, that jet is one of two coming off the polar regions of the black hole itself, correct? Or
Yeah,
I mean,
I think,
90 degrees to the accretion disk.
yeah, I think it's actually, you're right. I think that's a jet coming from the supermassive black hole, the SMBH, in the middle of the Virgo Galaxy. Interesting thing about these elliptical galaxies is that they don't have a whole lot of gas left in them and a whole lot of dust anymore. Spiral galaxies like ours, the Andromeda, Measure 33 that Lubo mentioned earlier, those are galaxies full of all kinds of debris and dust and clouds of ionized gas. The ellipticals are far cleaner in their design, which is kind of weird. They don't have as much dust at all. Although the one in Andromeda, when you look at Measure 110, which is in the way we're taking pictures of it, the upper, more elliptical galaxy, you actually see a bar of dark dust in that galaxy. Rare for an elliptical galaxy, but it's there. So interesting how this one here, Measure 87, it's basically just a big sphere of stars. There's very little gas, very little dust. And it's hard. We don't know as astronomers how these particular galaxies evolved. We don't know what caused them to be stripped of all the dust and gas. But in galaxies like this, star formation is essentially done. They're just stars that exist since the time they were created some time ago, and the last of the gas and dust was used up effectively, or was migrated out by some collisional process with another galaxy. It's unknown. And that's what makes astronomy so amazing, is that we're always learning. Look at that.
Izabela, no, Yes, the Virgo Galaxy is in the Virgo cluster. Uh, it's at the heart of the Virgo cluster. It's the biggest gravitational influence in the Virgo cluster. But yes, I would say that absolutely it's in the supercluster too.
Yeah, it's in the heart of the supercluster, actually.
Yeah.
Yeah. And this jet here is becoming even more pronounced. It's much easier to see, I think. I'll test it another way, but when you pull this mid-level down and remove the glow of the outer areas, it becomes more visible. See? It's very, very
It is
clear
obvious now.
Now, if we just do a process to the way it wants to be, this is what we get. And although you can still see it, it's muddied by the overall glow of the rest of these billions of stars. So let me see if I can get us back.
My bad, in other words.
What's that?
My suggestion to increase the gain.
Oh, but yeah, that's okay. I mean, you gotta try it, right? We gotta try it. I didn't think it was gonna show up better, from some experience I had looking at it before. But look, there it is. It's pretty obvious. I bet you we'd see it really well at 100. You know?
100 what?
Gain.
Oh.
So what I'm going to do is I'm going to save it like this, and then I'm going to actually drop the gain to 100 again. And I'm going to do it again. Actually, I'm going to try and drop the gain to 50 and see if we can see it. This might be pretty cool. So
You're a madman.
I am. It may work, it may not. And then we'll be done for tonight. Good night, Curtis. Thanks for coming, man. Oh yeah, let's process though. Let's get that to work here. Okay. Yeah, that's way too close. We gotta pull that down. I think there's a happy medium, Daryl. You know, 50 might be way too low. You know? See, it's muddy. You know? So I think you're probably right. We do want a little better. Well, you can see it. There it is. Let's pull this back a little. So you can see it.
Yeah.
Yeah. All right. Well, that's very cool. I won't bore you guys with taking more images of it, but well, this is cool. Well, you guys, we're gonna wrap it up for tonight. When summer rolls around too, trust me, we're gonna be having a blast because we haven't had this new camera on the sky in the summer yet, and so this is really gonna be amazing to see. You know, because this camera is much more tuned to this telescope. So let me back out of this in general. Now, is there anything else nearby that we can look at just as a quickie? We can't see M13 yet. We can see this guy, but M13 is still a little low.
Stop right there.
Okay.
Folks, if you notice up in the upper right, the bright star Arcturus, constellation Bodes, that's Corona Borealis, where the nova is going to happen. Down there, right there to the lower left of Arcturus.
T Corps Bor.
Yeah. And if you like draw a line from Arcturus to M13 there, Great Star Cluster and Hercules, you see Corona Borealis lies right on the line between them. And where T Corona Borealis is, I don't know if they would have that in Stellarium yet, but it's just a little bit below Mark's pointer.
Okay, so let's go in here. Now, it's probably not one of these main stars, right?
No, it's not. It's, you see the bright star,
Alphecca?
not Alphecca, but the one to the lower left you were near.
Right here?
Yes, it's to the lower, it's below that.
Okay.
It's a little bit outside the circlet.
So it's down here somewhere.
Yes.
I don't think it's being well, let's see. Do you know what its magnitude is?
It's presently about 10th mag.
Okay.
I'm sorry, I didn't mean to distract you.
No,
I
that's fine.
I saw Corona Borealis there. I thought I'd mention it.
No, that's a good point. Very good point.
Some good advice I saw recently. If you're curious about the nova, go out and identify Corona Borealis now. Take a picture of it with like your cell phone. And then whenever you hear the nova has happened, take another picture and refer to the old one, and you'll be able to identify the nova instantly by whatever new star appears in the constellation.
Now, you notice we're talking nova, not supernova, folks, and that's because
Right.
here's the thing. If you have a white dwarf and it's orbiting another star like a red giant, if that white dwarf is 1.3 solar masses and the red giant leaks hydrogen gas onto the surface, you can get to the point where that hydrogen gas can spontaneously fuse, and when that happens, you get a nova. And if the mass of that hydrogen increases the mass on the white dwarf to past 1.44 solar masses in mass, that would actually cause that to explode. And that's what's called a type 1a supernova. But a nova is just a recurring situation where you have this larger star orbiting the smaller star orbiting it, the white dwarf, leaking gas onto the surface of the white dwarf, but it never reaches that critical mass of 1.44. Maybe it gets to 1.41, 1.42, and thus it'll eventually go into runaway fusion, and it can do this periodically, and it's can be like clockwork. So that's kind of cool. So that's what the difference is between a nova and a supernova. Supernovas occur once.
The nova, I read, if T Corobora right now is estimated at 10th magnitude, when the nova happens, it may reach magnitude 2.5.
You can see it with your eye.
It'll be visible, but it won't be a standout object like a supernova would.
It's still visible to your eye.
Right. Middle of bright star.
Yeah. Okay. Alright, I'm just going to go to Measure 53. It's a pretty nice little... Let me just go here and do that. Okay. Okay, there it is. And let me try something here. I don't want to do that much. Okay, so now let's head to the east a little bit. So I lied. We're going to do this one more object. For those of you that are holdouts. Hey, City Lights, what's up?
C. Ramos has a question of you.
Claudio, yes. He says, how much energy use? Okay, what's the electrical budget for this telescope? It's not that much. It's in the milliamps. When it moves the motors, we might approach an amp or so, but you got to keep in mind that we're a green observatory, so all of our energy is free from the sun. We have solar panels on the site that we use. At the Benson site, we're going to have city electric, so we're not going to have any disruption to our electrical like we do here sometimes. Okay, let's do 10 seconds. Okay, we'll get rid of this. Then we come in here, get rid of the last image. There it is. I'll save it anyway. Oh, no, I won't. Okay.
What happened?
Oh no, it I should have saved it earlier. I didn't really want to because it was at that lower level. I'm at 53 still.
Oh,
Well, it might be okay for this. That's the thing. Let's find out. Are we? Oh, we're in the red. Okay, that's why. There we go. So now we'll get one. Yeah. Color correct. There's measure 53.
yeah.
The stars are actually a little elongated. I think I started the exposure before I had my guide stars. Let's do this one more time. This next exposure should be nice and clean. Yep. No, not quite.
Nice globular.
It is. The stars are not perfectly round.
Wind?
Yeah. Yeah, okay. Well, we got away with it for a while, guys, without having to worry about wind, but we have a little bit of a breeze out there right now. So, alright, so here's what we're going to do. The gain is at 53. It's obviously low. But we're, when I'm going to set it to 200 anyway. Say 250 again. And then clear. And do one more. It'll be a mix. Okay, let's do this and this, color correct and match. All right, there we go. Yeah, you see the stars are a little elongated. And we can use focus again. But we're not going to do that because we're going to pack it up. All right. It is a really pretty globular, though.
It is.
Let's see here.
Oh God,
What?
Ghostbusters 2 is coming on.
Hey, it's not as bad as the latest Ghostbusters.
I bet. The thing I like best about Ghostbusters 2 is Annie Potts. I think she's adorable in this. And she dyed her hair red.
Mm.
Plus, she looked like she'd been working out a lot.
Okay, let's drop this over here. Okay. And then drop this down here. That's pretty.
It is.
Yeah. Okay, let's go here. We'll call it Measure 53, M53. This is the bonus object for tonight. It's a GC Globular Cluster. And we'll save it with 11 exposures. So what will be saved out there will be this image right here. This is the image you can get. I think that it's slightly out of focus too, see? Actually, I've got artifacts on these stars. I think we had some movement from the wind.
Yeah.
Yeah. Well, let's okay, one more time. I'm going to clear this. And this next shot should supersede. And let's see how that's going to look. Yeah, this is still doing what it's doing. All right. Okay, hold on.
Lewis, the cluster is Messier 53. It's a globular cluster.
Oh yeah, hey Lewis. Lewis TA, what's up? Okay, here's what we're gonna do. We are going to do a 20-second shot of this because we don't need any more. And actually, before we do that, I'm gonna do something else. I'm gonna actually do a focus run. Let's do this. Let's go down to 25 again. Too few stars. What's going on? We got clouds? No. Here's our AllSky camera, by the way. A few bird turds. And as far as constellations go, we just click this and it shows you Arcturus and Bodes over there. And all the Messier objects in here. You highlight them and you can then go to them and see what they're all about. And we have our time lapses our star trails. Star trails are pretty. So let's see if we have one for last night. Yeah, we do. Here it is. Look at that.
Bird bombs.
Huh?
Bird bombs.
Did you say bird bombs?
Yes.
Yeah. Okay, you can see meteors that come in, like right here. See a meteor there. Satellites all throughout. And let's see here. Come on, come out of there. Yeah, I mean, look how many stars there are. You literally don't. It's hard to see anything. And this is the leftover horizon when the sun set. So this is like a summary of the whole night. Pretty cool. All right. Yeah. And then the Milky Way will be rising over here. You can see Scorpio is rising right here. Let me see if that's visible yet. Yeah,
Yep.
Antares. Yeah. You can see the 3 stars and Antares rising, coming right up there. So it's on its way.
Those 2 stars to the right are Libra.
Yeah,
Zuminus Shamaili and Zuminil Tanubi.
yeah.
And below to the lower right of those 2 is Spica and Virgo.
Yeah. That's Spica right there, I think. Or is that Arcturus? That's Arcturus. You see, there's the kite shape of Arcturus.
Yeah.
Yep. All right. Well, cool.
Did we get lost or something?
No, why?
I thought we were looking at Messier 53. I thought you were going to do the focus run.
Yeah, I am. But I thought I had clouds, so I came back to look.
Ah,
And I see that, my gain is at 250. Oh, and there's the problem. Duh. All right. I see what the issue is. Now watch the difference. Boom. That's better. Okay. So we're going to defocus a little bit. Right, it says too few stars, that's fine. And then we gotta try this here. Hey, Woo Riders DG, what's going on? How's Florida? I'm with you, USA, USA, USA. Right, so we're just focusing right now. You see more stars coming in. See, I can't pass up a good night. So this is why it's like, I'm just one more, that's me. Just one more. Alright, so let's see here. Just remember, guys, if you can make contact in the desert, I'll be doing a stream out there live with the studio audience. I also will be giving away in both my workshop and my intensive lecture, 3-hour long lecture. We'll be giving away equipment binoculars and telescopes while I'm there in those 2 talks. So I would love to have you guys come there and win. We're also, after contact, we're going to start running contests here within a normal Sky Tour, and you'll have the option to actually win equipment that way as well. Okay. And then we publish it on our website. So we're going to do 20 seconds here. And we're going to go out of our low light view and go into our stack. That's measure 53 from before when it was out of focus. And now it's going to be sharply focused in my estimation. And we're going to see a much different view. There we go. Oh, that's pretty. Yeah, now look at those stars. Nice little pinpoints. Look at that. No double stars anymore. No stacked anomalies. That's pretty. Now that's a beautiful image. And let's match our curves just to get a little bit better. There we go. And for stars, you can come over the edge just a little bit, just to get them a little darker. You can come over the top of the curve. Right, so now what we'll do is come down here and drag this down. All right. Okay, so that's nice. Dean, thank you. I'm glad you like this image. It really is pretty with this one red star in it, you know. I knew, I mean, even though I'm getting tired, I had to do this because this is just too pretty an image to just let it go. So I figured, okay, we got 4 saved right now, 4 stacked. We're gonna go a couple more and allow it to just capture really well here. Get rid of some of the noise. Look at that. Look at how that looks. Actually, this will be the only one of the night that we do this with, but let's first let's get rid of this. And let's move the telescope out of the way here for now. And let's just check out the view from measure 53. Look at that. That's just beautiful. That's really pretty.
It is. And the red star gives a nice color contrast too.
Yeah, that's what I was saying. That's nice. You got another one right here. And some of the stars in the cluster are a little bit different. These stars are all formed at the same time, but the clusters do age, and the stars will move past the main sequence phase and stop fusing hydrogen into helium. But when they go to a red giant, they're not going to be able to go any further. They won't be able to likely fuse helium into carbon unless they're more massive than the sun. The sun will be able to do it too, but it's going to be interesting to see that happen. Okay, let's come in here for a sec. And let's drag this down even further. It helps resolve the core. See that? Look at that. Now we can zoom in. Look at, you can see the stars right into the core. Oops, sorry. Let's go here. Oh, I guess maybe that's... All right. Oh, wrong number. Sorry, wrong thing. There we go. Wow. That's nice. You gotta love the autofocus on this thing. That's a really nice spherical globular cluster. It doesn't seem to have any disturbances to it from gravitational interaction with the galactic disk. This is a halo object that goes, it's outside the galaxy and circumnavigates the poles of the galaxy and then goes down through the disks and then comes back up through. So it's pretty cool. Woo Riders asked the question: have I ever seen UFOs? Yeah, actually, we've caught some on our AllSky camera. Really strange objects making pirouettes in the sky. So absolutely, we've seen them, and that's I'm the MUFON chief photo and video analyst, so that's for worldwide. So we have hundreds of thousands of cases in our database. And so, obviously, most of them are known objects captured in an extraordinary way. But still, it's pretty interesting to see them. And there are some things that have been unknown. And I've seen an unknown on this camera that I cannot explain. And so far, nobody has. All right, let's redock this now. Let's bring back the telescope. Just a minute here. Okay. Let's save this as M53 Globular Cluster and save it as exactly as seen. And then I'll click on it and show you what you're going to get. This will be out on the server. Look at that. So you can just crop it. Look at that. What a beautiful image. That's really pretty. So let's try now. Let's see what it wants to do in terms of adjustments. Okay. That's fine.
Lewis, we don't know the answer to your question. He says, is that red star a giant in its last days? We'd have to identify the star first, and we could look it up.
Well, why don't we do that? Let's see here. It's this star here. And the star, see, they don't give it a name. It's magnitude 9 star. But you can go by the sidereal, by the right ascension declination coordinates, and you can probably find it in the SEDS database. That's SEDS. Okay. Wow, that's cool. Okay, 21. I'll go to 22 here. And boom. All right, now we'll save it. Save exactly as seen. So one was saved a little darker than the other. Hope you guys like this new music. You'll hear some of the songs you've heard before, but most of it's brand new. All right, guys. Well, now I will officially close up. And it was really good to see you guys and hang with you. I enjoy doing this a lot. So, again, go to skytourlive.org and check out everything that's up there. You can get these images from there. Go to our server from there. Follow Izabela's and Daryl's links as well. Also, if you guys are of a mind to, I would love to have you join our Patreon. If you become a Patreon member, there's benefits above a certain amount. You can have access to our finished processed images that are worthy of framing and worthy of making a very, very sorry. You can take our images and they're, like I said, they're worthy of framing at certain size, and we produce them at the highest resolution possible for you. Also, if you just want to get some cool stuff and merch, you can go to our Etsy store, which is up here. It's called Sky Tour Shop. That's on Etsy. So you want socks with the nebula on it. All images we've taken on sneakers, mouse pads, mugs, coffee cups, travel mugs, and dozens of other products up there on Sky Tour Shop. So check it out. It's fun. Playing cards, coasters. We have it all. Anyway, we are a non-profit company, and we do depend on your generous support. So if you can join our Patreon and support us, that'd be great. Every little bit helps. So you guys have a good night, and I hope that you will come back again. I see a lot of people here that always come back again. Love you guys. So we will talk soon. So you have a good night, and remember, keep looking up. All right, everybody? So we'll see you later.
Good night, everybody.
Night-night.